Hello everyone, my name is Jorge Parra and I study in the Alcántara HS of Alcantarilla, Murcia, Spain, and I'm going to present to you my research project which is called PORTMÁN, a weight problem, the paradigm on soil contamination. PORTMÁN is a coastal village of the region of Murcia located at the foot of the Sierra Minera La Unión Cartagena, who is popularly known for its bay, whose environmental problems have been the main concern for the village since the middle of the 20th century until nowadays. In this research, the following objectives were proposed. First of all, to make a research about the historical pollution of the area and to see how it has evolved over the centuries. To analyze soil and water samples looking for heavy metals and to compare the problem and control areas. To determine if soil contamination causes the ecosystem to degrade. To analyze the emblema study and to contrast both sides of the social problem that has emerged directly from the bay. To determine if there is a potential risk for the inhabitants of the Sierra Minera, and last of all, to extrapolate the research to other fields. In order to achieve those objectives, a specific methodology has been used. First of all, the collection and preparation of soil and water samples and their analysis with the technique of the optical emission spectrometry. This took various steps, starting with drying and sieving the samples, so we can apply an acid digestion with 25 milliliters of hydrogen peroxide and nitric acid. So we analyze the micro and macronutrients. Then we'll do some plant cultivation. And last of all, we'll do some interviews to know more about the problem that we are talking about. Two of these interviews was made to both sides of the social problem. And the last one was made to know more about the historical contamination. But in order to know the context of the village and its relation with minor activities, we have to know its history. Since the Neolithic era, there were small communities here, but it was not until the pre-Roman and the Roman Empire times when PORTMÁN had its gold era. But the problem that we are talking about starts in the middle of the 20th century. In 1957, the largest facility of all Europe dedicated to the manual processing was installed in PORTMÁN, and in 1959, they were authorized to dump the residues directly to the bay. So the social protests were rising, and in 1986, a massive protest by Greenpeace went quickly around the world. Finally, in 1990, the dumping activities were closed. With more than 60 million tons and 75 hectares filled up with minor sterile pollutants, we face one of the biggest environmental problems of all Spain and Europe. But which problem are we talking about? We have a series of soils full of minor pollutants, so we face a serious case of soil contamination. But first of all, we should define some concepts. Soil can be defined as the final product of the influence of a series of active factors like climate and topography on a passive and parental material, the bedrock and minerals, which form the superficial layer of the Earth's crust. And a pollutant substance is the one that it's not in its natural environment, or it belongs to the environment, but its concentration is higher than it should be, so it causes negative and counterproductive effects. There is a lot of substances that are pollutant, but in this research we have focused on the heavy metals, which are elements with a metallic nature whose density range between 4 and 7 grams per cubic centimeter and have potentially contaminating characteristics such as bioaccumulation or biomagnification. In Spain, the normal compositions of the soils is given by the generic reference levels. Now I'll start the experimental design, starting with the soil analysis. There were 14 collection points for soil samples. 7 of them were in the problem area within the mining area of PORTMÁN, and the 7 other samples were taken in the control area in the Alcantarilla municipal area. So the preparation took various steps. First of all, we collected and sorted the samples, and then we dried, sieved the samples to take them to the analysis facilities where they spent 2 days in a heater. The problem soils in the vast majority of the samples far exceed the generic reference levels imposed for the area. Highlighting some elements such as arsenic, lead, and zinc, we can see how those concentrations exceed the normal levels that are supposed to have. On the other hand, the control soils are, in general, quite in line with the NGR defined for them. If we highlight the same elements as before, we see that arsenic, as well as lead and zinc, keep their concentration in line with the normal level expected. The following graphics show how in the problem soils, all the heavy metal concentrations greatly exceed the values obtained for the control soils. Besides that, the problem soils keep a great tendency to contamination, as we see in the graphics. So the analysis carried out has allowed us to obtain the concentrations of most of the elements of the periodic table. The final comparison is that all heavy metals increase their concentrations in the problem soils, with the largest increases for arsenic, lead, and zinc. Concerning to the rest of the elements, quite high increases are still observed in the mining area soils. For the water analysis, we took two samples were collected in the problem area, in the PORTMÁN Bay, and the control sample was taken at a tap in my high school. So the only preparation was using a water filter to put the samples directly on the sample carriers. From the results obtained, it's only worth mentioning the high hardness of the water taken in the problem area, as we see in their concentrations of calcium and magnesium. The plant cultivation was made with the idea of analyzing the influence of the soil on the ecosystem and to verify whether or not the presence of contaminants affect the development of life, trying to extrapolate the conclusions to the entire ecosystem. So the idea was to grow crops with soil as the only variable and to add substrate to see the effects. We concluded doing 4 crops of red radish with 4 seeds per crop. The crops started growing on the 12th November 2019, and they were growing until the 6th of January 2020, when the experiment finally ended. Analyzing the leaves, because there was no radish fruit, we can see how those obtained in the problem area are fewer and less heavy. In addition, the problem area crops had a visual appearance much unhealthier than the control ones. So concluding, we can see that the crops developed in the control soils developed way better than the problem ones, and the addition of substrate did not lead to an improvement. So the influence of soil on crops has been clearly shown. The presence of pollutants affect directly to the development of life and the homeostasis of the ecosystems. The main objective of the emblema study was to compare directly samples from the mining and non-mining area to determine whether or not there is a potential risk for the health of the inhabitants of the Sierra Minera. In children, concentrations are almost the double in the mining area. In mother, quite high increases are still observed, although not as much. In lead, we have a higher concentration in children because they are exposed directly to those residues. Concentrations in mothers can be explained because in the past, the gasoline with lead was allowed. The concentrations of mothers with cadmium can be explained because of the influence of tobacco. And last, for the arsenic, the data would be approximately even, although a small increase could be even seen in the non-mining area. From the interview with the emblema study technicians, we highlight, among others, the following conclusions. The presence of mining waste is not denied, but many factors should be taken in consideration. So the increases in the mining area are the same as years ago, but with lower values. So for them, there is no potential risk. These ideas clash head-on with the conclusions of the interview with the pump responsible, on which we highlight that the regional administration would have a denialist attitude and would try to divert the attention with impossible action plans. So the solution would be to enforce environmental regulations and keep the residues stabilized. So for him, the population of the Sierra Minera continues to be at risk. In conclusion, the PORTMÁN Bay has gone down in history as the scene of one of the most serious contamination cases of all the Mediterranean, where the main pollutants are heavy metals, arsenic, cadmium, and lead, and the main source of non-labor exposure is the digestive one. The Sierra Minera soils, the high cost of the necessary actions have led an unhealthy panorama of pollution, where the Sierra Minera soils fairly exceed the NGR defined for them, and they affect dearly to the development of life and the homeostasis of the ecosystems. Neighborhood protests and social problems have never stopped because they keep finding safety problems with residues. So it could be necessary to think about the consequences of our activities, and a more severe environmental legislation could be needed to solve the problems of the inhabitants of the Sierra Minera. Now I present to you the bibliography and webgraphy used for this project, and I want to thank everybody who has been supporting me and who has helped me doing this project, especially to the Congress organization for letting me presenting the results of my research project. Thank you very much for your attention.
Thank you for your presentations. Are there any questions?
I have a question, if I may. Thank you for your presentation. It was very interesting. What method did you use for quantitative analysis of soil samples for heavy metals?
We use the analysis by optical emission spectrometry. It's called the ICP-OEs because it's the abbreviation of inductive cold plasma optical emission spectrometry. And we did this on the facilities of the CESIC Center here in the University of Murcia. And that's the method that we used.
Thank you very much.
Thank you.
May I ask the question? Do you have any suggestions to soil recultivation, for example?
Can you repeat?
What can we do to recultivate the soil, to decontaminate it?
Oh yes, that's a very interesting question that actually we were trying to answer, but the actions that we could do is stabilizing the residues, because it would be impossible to eliminate all the residues because there are more than 65 hectares full of polluting substance. So the bay is completely filled up with minor pollutants. So the main action that we could actually do is to stabilize the residues and try to them to not have an environmental effect directly to the bay. So we regenerate the bay and keep the residues stabilized.
And do you know that in Canada they had the same problem with mining and with industries, metal, for example, industries, and they already recultivate the big area by planting grass and trees and so on. Do you know about it?
Yeah, we were talking with the PAM responsible about this kind of projects, and he told us that we could do a plan for just regenerating some fields of the bay, not the entire bay, but we could do like parts of the bay. We could try to just stabilize the residues and plant some trees or that for the soil to regenerate the natural cycle of the elements of the soil. And we could do this with parts of the bay, and in an ideal case, it would be the final result, it would be all the bay regenerated. But it's true that we have to take in consideration also the economy of the area, because this is a little bit depressed, economically depressed area. So many factors should be taken in consideration. So the ideal case, obviously, is regenerating the bay, but the regional administration would try to do its best.